Part 2, Chapter 3 of A Popular History of Astronomy During the 19th Century. This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. Recording by Lawrence Trask, Mount Vernon, Ohio, interfaceaudio.com. A Popular History of Astronomy During the 19th Century by Agnes Mary Clerke. Chapter 3. Recent Solar Eclipses. Part 3. The total eclipse of December 22nd, 1889, held out a prospect, unfortunately not realized, of removing some of the doubts and difficulties that impeded the progress of coronal photography. Messrs. Burnham and Skibbereen secured at Cayenne some excellent impressions, showing enough of the corona to prove its identical character with that depicted in the beginning of the year, but not enough to convey additional information about its terminal forms or innermost structure. Any better result was indeed impossible, the moisture-laden air having cut down the actinic power of the coronal light to 1/4 its previous value. Two English expeditions, organized by the Royal Astronomical Society, fared still worse. Mr. Taylor was stationed on the west coast of Africa, 100 miles south of Luanda. Father Perry chose as the scene of his operations the Salut Islands, off French Guiana. Each was supplied with a reflector constructed by Dr. Common, endowed by its extremely short focal length of 45. Combined with an aperture of 20 inches, with a light concentrating force capable, it was hoped, of compelling the very filmiest coronal branches to self-registration. Had things gone well, 2 sets of coronal pictures, absolutely comparable in every respect, and taken at an interval of 2 hours and a half, would have been at the disposal of astronomers. But things went very far from well. Clouds altogether obscured the sun in Africa. They only separated to allow of his shining through a saturated atmosphere in South America. Father Perry's observations were the last heroic effort of a dying man. Stricken with malaria, he crawled to the hospital as soon as the eclipse was over, and expired 5 days later, at sea, on board the Comus. He was buried at Barbados. And the sacrifice of his life had, after all, purchased no decisive success. Most of the plates exposed by him suffered deterioration from the climate, or from an inevitably delayed development. A drawing from the best of them by Miss Violet Common represented a corona differing from its predecessor of January 1st, chiefly through the oppositely unsymmetrical relations of its parts. Then the western wing had been broader at its base than the eastern. Now the inequality was conspicuously the other way. The next opportunity for retrieving the mischances of the past was offered April 16, 1893. The line of totality charted for that day ran from Chile to Senegambia. American parties appropriated the Andes. Both shores of the Atlantic were in English occupation. French expeditions, led by Delandres and Bijourdin, took up posts south of Cape Verde. A long totality of more than 4 minutes was favored by serene skies, hence an ample store of photographic data was obtained. Professor Skibbereen of the Lick Observatory took, almost without assistance, at Mine Bronces, a mining station 6,600 feet above the Pacific, 52 negatives, 8 of them with a 40-foot telescope, on a scale of 4½ inches to the solar diameter. Not only the inner corona, but the array of prominences then conspicuous, appeared in them to be composed of fibrous jets and arches, held to be sections of elliptic orbits described by luminous particles about the sun's center. One plate received the impression of a curious object, entangled amidst coronal streamers, and the belief in its cometary nature was ratified by the bestowal of a comet medal in recognition of the discovery. Similar paraloidal forms had nevertheless occasionally been seen to make an integral part of earlier coronas, and it remains extremely doubtful whether Schaeberle's eclipse comet was justly entitled to the character claimed for it. The eclipse of 1893 disclosed a radiated corona such as a year of spot maximum was sure to bring. An unexpected fact about it was, however, ascertained. The coronal has been believed to have much in common with the chromospheric spectrum. It proved on investigation with a large prismatic camera, employed under Sir Norman Lockyer's directions by Mr. Fowler at Fundium, to be absolutely distinct from it. The fundamental green ray had on the West African plates 7 more refrangible associates, but all alike are of unknown origin. They may be due to many substances, or to one. Future research will perhaps decide. We can at present only say that the gaseous emissions of the corona include none from hydrogen, helium, calcium, or any other recognizable terrestrial element. Delandre's attempt to determine the rotation of the corona through opposite displacements, east and west of the interposed moon, of the violet calcium lines supposed to make part of the coronal spectrum, was thus rendered nugatory. Yet it gave an earnest of success by definitely introducing the subject into the constantly lengthened program of eclipse work. There is, however, little prospect of its being treated effectively until the green line is vivified by a fresh access of solar activity. The flight of the moon's shadow was on August 9, 1896, dogged by atrocious weather. It traversed, besides, some of the most inhospitable regions on the earth's surface, and afforded at the best but a brief interval of obscurity. At Novaya Zemlya, however, of all places, the conditions were tolerably favorable, and as we have seen, the trophy of a flash spectrograph was carried off. Some coronal photographs, moreover, taken by the late Sir George Baden-Powell and by M. Hansky, a member of a Russian party, were marked by features of considerable interest. They made apparent a close connection between coronal outflows and chromospheric jets, cone-shaped beams serving as the sheaths or envelopes of prominences. M. Hansky indeed thought that every streamer had a chromospheric eruption at its base. Further, dark veinings of singular shapes unmistakably interrupted the coronal light, and bordered brilliant prominences, reminding us of certain black lines traced by Swift across the anvil protuberance, August 7, 1869. In type, the corona of 1896 produced that of 1886, as befitted its intermediate position in the solar cycle. The eclipse track on January 22, 1898, crossed the Indian peninsula from Viziadrug on the Malabar coast to Mount Everest in the Himalayas. Not a cloud obstructed the view anywhere, and an unprecedented harvest of photographic records was garnered. The flash spectrum, in its successive phases, appeared on plates taken by Sir Norman Lockyer, Mr. Evershed, Professor Campbell, and others. Professor Turner set on foot a novel mode of research by picturing the corona in the polarized ingredient of its light. Mrs. Maunder practically solved the problem of photographing the faint coronal extensions, one ray on her plates running out to nearly 6 diameters from the moon's limb. Yet she used a Dallmeyer lens of only 1½ inches aperture. Her success accorded perfectly with Professor Wadsworth's conclusion that effectiveness in delineation by slight contrasts of luminosity varies inversely with aperture. Triple-coated plates and a comparatively long exposure of 20 seconds contributed to a result unlikely for some time to be surpassed. The corona of 1898 presented a mixed aspect. The polar plumes due at minimum were combined in it with the quadrilateral ogives belonging to spot maxima. A slow course of transformation, in fact, seemed in progress, and it was found to be completed in 1900, when the eclipse of May 28th revealed the typical halo of a quiescent sun. The obscurity on this occasion was short, less than 100 seconds, but was well observed east and west of the Atlantic. No striking gain in knowledge, however, resulted. Important experiments were indeed made on the heat of the corona with Langley's bolometer, but their upshot can scarcely be admitted as decisive. They indicated a marked deficiency of thermal radiations, implying for coronal light, in Professor Langley's opinion, an origin analogous to that of the electric glow discharge, which at low pressures was found by K. Ångström in 1893 to have no invisible heat spectrum. The corona was photographed by Professor Barnard at Wadesboro, North Carolina, with a 61.5-foot horizontal celiostat. In this instrument, of a type now much employed in eclipse operations and first recommended by Professor Turner, a 6-inch photographic objective preserved an invariable position, while a silvered plane mirror, revolving by clockwork once in 48 hours, since the angle of movement is doubled by reflection, supplied the light it brought to a focus. A temporary wooden tube connected the lens with the photographic house where the plates were exposed. Pictures thus obtained with exposures of from 1 to 14 seconds were described as remarkably sharp and perfectly defined, showing the prominences and inner corona very beautifully. The polar fans came out magnificently. The great Sumatra eclipse left behind it manifold memories of foiled expectations. A totality of above 6 minutes drew observers to the far east from several continents, each cherishing a plan of inquiry, which few were destined to execute. All along the line of shadow, which on May 18, 1901, crossed Réunion and Mauritius, and again met land at Sumatra and Borneo, the meteorological forecast was dubious, and the meteorological actuality in the main deplorable. Nevertheless, the corona was seen and fairly well photographed through drifting clouds, and proved to resemble in essentials the appendage viewed a year previously. Negatives taken by members of the Lick Observatory expedition led by Mr. Perrine disclosed the unique phenomenon of a violent coronal disturbance with a small compact prominence as its apparent focus. Tumbling masses and irregular streamers radiating from a point subsequently shown by the Greenwich photographs to be the seat of a conspicuous spot suggested the recent occurrence of an explosion, the far-reaching effects of which might be traced in the confused floccular luminosity of a vast surrounding region. Again, photographs in polarized light attested the radiance of the outer corona to be in large measure reflected, while that of the inner ring was original, and the inference was confirmed by spectrographs, recording many Fraunhofer lines when the slit lay far from the sun's limb, but none in its immediate vicinity. On plates exposed by Mr. Dyson and Dr. Humphreys with special apparatus, the coronal spectrum, continuous and linear, impressed itself more extensively in the ultraviolet than on any previous occasion, and Dr. Mitchell succeeded in photographing the reversing layer by means of a grating spectroscope. Finally, Mrs. Maunder, at Mauritius, despite mischievous atmospheric tremors, obtained with the Newbegin telescope an excellent series of coronal pictures. The principles of explanation applied to the corona may be briefly described as eruptive and electrical. The first was adopted by Professor Scheiberle in his mechanical theory, advanced in 1890. According to this view, the eclipse halo consists of streams of matter shot out with great velocity from the spot zones by forces acting perpendicularly to the sun's surface. The component particles return to the sun after describing sections of extremely elongated ellipses, unless their initial speed happen to equal or exceed the critical rate of 383 miles a second, in which case they are finally driven off into space. The perspective overlapping and interlacing of these incandescent outflows was supposed to occasion the intricacies of texture visible in the corona, and it should be recorded that a virtually identical conclusion was reached by Mr. Perrine in 1901, by a different train of reasoning, based upon a distinct set of facts. A theory on very much the same lines was, moreover, worked out by M. Bélopolsky in 1897. Scheiberle, however, had the merit of making the first adequate effort to deduce the real shape of the corona as it exists in 3 dimensions from its projection upon the surface of the sphere. A theory on very much the same lines was, moreover, worked out by M. Bélopolsky in 1897. Scheiberle, however, had the merit of making the first adequate effort to deduce the real shape of the corona as it exists in 3 dimensions from its projection upon the surface of the sphere. He failed, indeed, to account for the variation in coronal types by the changes in our situation with regard to the sun's equator. It is only necessary to remark that, if this were so, they should be subject to an annual periodicity of which no trace can be discerned. Electromagnetic theories have the charm and the drawback of dealing largely with the unknown, but they are gradually losing the vague and intangible character which long clung to them, and the improved definition of their outlines has not, so far, brought them into disaccord with truth. The most promising hypothesis of this kind is due to Professor Bigelow of Washington. His able discussion of the eclipse photographs of January 1, 1889, showed a striking agreement between the observed coronal forms and the calculated effects of a repulsive influence obeying the laws of electric potential, also postulated by Huggins in 1885. Finally, subdivided matter, expelled from the sun along lines of force emanating from the neighborhood of his poles, thus tends to accumulate at equipotential surfaces. In deference, however, to a doubt more strongly felt then than now whether the presence of free electricity is compatible with the solar temperature, he avoided any express assertion that the coronal structure is an electrical phenomenon, merely pointing out that, if it were, its details would be just what they are. Later, in 1892, Pupin in America and Ebert in Germany imitated the coronal streamers by means of electrical discharges in low vacua between small conducting bodies and strips of tinfoil placed on the outside of the containing glass receptacles. Finally, a critical experiment made by Ebert in 1895 served, as Bigelow justly said, to clear up the entire subject and put the theory on a working basis. Having obtained coronoidal effects in the manner described, he proceeded to subject them to the action of a strong magnetic field, with the result of marshalling the scattered rays into a methodical and highly suggestive array. They followed the direction of the magnetic lines of force, and, forsaking the polar collar of the magnetized sphere, surrounded it like a ruffle. The obvious analogy with the aurora polaris and the solar corona was insisted upon by Ebert himself, and has been further developed by Bigelow. According to a recent modification of his hypothesis, the latter appendage is controlled by 2 opposing systems of forces, the magnetic causing the rays to diverge from the poles toward the equator, and the electrostatic urging their spread, through the mutual repulsion of the particles accumulated in the wings, from the equator towards either pole. The cyclical change in the corona, he adds, is probably due to a variation in the balance of power thus established, the magnetic polar influence dominating at minima, the electrostatic at maxima, and he may feel well encouraged by the fortunate combination of many experimental details into one explanatory whole, no less than by the hopeful prospect of further developments, both practical and theoretical, along the same lines. What we really know about the corona can be summed up in a few words. It is certainly not a solar atmosphere. It does not gravitate upon the sun's surface and share his rotation, as our air gravitates upon and shares the rotation of the earth, and this for the simple reason that there is no visible growth of pressure downward, of which the spectroscope would infallibly give notice, in its gaseous constituents, whereas under the sole influence of the sun's attractive power their density should be multiplied many million times in descent through a mere fraction of their actual depth. They are apparently in a perpetual state of efflux from and influx to our great luminary, under the stress of opposing forces. It is not unlikely that some part at least of the coronal materials are provided by eruptions from the body of the sun. It is almost certain that they are organized and arranged round it through electromagnetic action. This, however, would seem to be influential only upon their white-hot or reflective ingredients, out of which the streamers and aigrettes are composed, since the coronal gases appear, from observations during eclipses, to form a shapeless envelope, with condensations above the spot zones, or at the basis of equatorial extensions. The corona is undoubtedly affected both in shape and constitution by the periodic ebb and flow of solar activity, its low tide form being winged, its high tide form stellate, while the rays emitted by the gases contained in it fade, and the continuous spectrum brightens at times of minimum sunspots. The appendage as a whole must be of inconceivable tenuity, since comets cut their way through it without experiencing sensible retardation. Not even Sir William Crookes' vacua can give an idea of the rarefaction which this fact implies. Yet the observed luminous effects may not in reality bear witness contradictory of it. One solitary molecule in each cubic inch of space might, in Professor Young's opinion, produce them, while in the same volume of ordinary air at sea level the molecules number, according to Dr. Johnstone Stoney, 20,000 trillions. The most important lesson, however, derived from eclipses is that of partial independence of them. Some of the fruits in the daily study of prominences the next chapter will collect, and the harvest has been rendered more abundant, as well as more valuable, since it has been found possible to enlist, in this department too, the versatile aid of the camera. End of Chapter 3. Recording by Lawrence Trask, Mount Vernon, Ohio. InterfaceAudio.com.